Okay, now let's look briefly at the impact of intra-seasonal variability or the monsoon intra-seasonal oscillations, MISOs, on the predictability of the seasonal mean rainfall, which is a very important factor. It's been shown that the total seasonal rainfall over all India, which is typically referred to as IMR, India monsoon rainfall, or AIMR, All India monsoon rainfall. They are highly correlated with total food production and economy and so on. And the statistical methods that have been used for a long time in India, obviously, they have not shown any real skill. They are good at predicting a normal year, but they tend to miss the excess or deficit years. And dynamic forecasting that has started recently has shown skill for all India monsoon rainfall, but now there is demand for spatial distribution of the rainfall. So the predictability of seasonal totals obviously has a high value, and as we saw before, the all India monsoon rainfall tends to remain most of the years within plus minus 10% of the long-term mean. There are separate science questions about why that would be, but the predictability itself is here argued to be related to MISOs via these lines of arguments. You look at the seasonal total rainfall here. You have the Western Ghats and offshore maximum here. You have the Bay of Bengal maximum, core monsoon zone, and the marine ITCZ that we talked about. And you look at the structure and amplitude of the 30 to 60 day mode, and it has a similar maxima and a maxima here and so on. And you can look at other variables like the 850 hectopascal winds of the 30 to 60 day mode and so on. You can argue that there is a great similarity between the 30 to 60 day mode and the seasonal rainfall. And the argument, as we did before, looking at the different years and the distribution of active and break periods, we said that wet years tend to have more active periods with fewer break periods, whereas deficit years have more break periods, longer break periods, and fewer active periods. The argument then is that the interannual variability of the seasonal total is related to the distribution of active and break periods. This is possible because the active and break periods are not fixed in periods. They do change from year to year, so you can make them add up to a different total, as we saw before, each year. And this means that if you think of internal variability and external variability, in the tropics generally the slowly varying sea surface temperature conditions of the ocean, because of its high heat capacity, can give you predictions at climate time scales, even though the weather itself may be going chaotic in a few days. So you have so-called predictability of the second kind, where the sea surface temperature modulation can give you El Nino predictions, for example. But if the active break periods are internal variability, in other words, they are not related to SST forcing in a strong way, or let's say El Nino is not affecting the active break periods very strongly and yet creating interannual anomalies by shifting their frequencies. It's kind of a funny way to say it, but nonetheless, you want to see where the predictability comes from. If internal variability is very high, then the system is generally not predictable. Okay, and we already said that only 50% of the droughts are related to El Nino, and 50% of the excess years are related to La Nina, which means there is a lot of internally generated wet and dry years, or maybe they are related to Atlantic Nino forcing and so on. Nonetheless, to continue this argument, Goswami looks at the First, EOF of intraseasonal and intraannual 850 hectopascal winds. Here you are looking at intraseasonal EOFs calculated using ISO filtered winds for the June, July, August, September. For 20 years, 1978 to 1997. This is the interannual EOFs calculated using the seasonal mean JJS winds for a 40-year period, 1958 to 1997. And you can see the great similarity between the two of them. And you can look at the Indian monsoon rainfall shown here in these empty histograms, and interannual PCs, principal components associated with the EOF of the interannual EOF, and you can see there is a high correlation between them. So the argument is that the intraseasonal variability is adding up to interannual variability, and this is possible because intraseasonal variability is not sinusoidal and fixed in frequency period. Hence, if intraseasonal variability is internal variability, then predictability remains low. So indeed, predictability of the seasonal total remains fairly low. Additional point is made in this paper by Ajay Mohan and Goswami, which I didn't cite here. It's from 2003, I think. It's cited in the chapter you can look up, where they take quantities like this, let's say OLR, and they split it into total variance, internal variance, and external variance. Of course, sigma squared is sigma E squared plus sigma I squared, so this can be written as sigma E squared divided by sigma I squared, external and internal, plus 1. When F is close to 2, then predictability is high. Okay, so if you take OLR as a measure for convection and rainfall, then you see that for the summer months there is predictability, or the F is high in some places, but over the Indian region it's fairly small. So there are tropical regions where there may be predictability, but the Indian region has very low predictability, whereas the winter season or India seems to have higher F and higher predictability, even though the rainfall over India during DJF is only limited to very small places where the northeast monsoon happens. Okay, so this is another way of saying that the external forcing of the intraseasonal variability is not very robust. We don't know of it yet. Hence, the predictability of the seasonal total is affected by the high internal variability generated by the intraseasonal variability. So predictability of the seasonal monsoon is limited by the intraseasonal variability, or MISOs. But we already said before that predictability of the active break periods themselves seems to be possible, at least out to beyond week 1, beyond weather timescales, which are called sub-seasonal timescales, so week 2 to 4, and that can still be very important for agriculture. Plus, we also said that the active periods cluster the low pressure systems and depressions, which tend to be related to the extremes, so predicting at that time scale can also help predict the extremes, as well as the rainfall break and active periods, especially critical for water resource management and crop calendar or agriculture. Of course, with the extremes increasing, becoming more widespread, there are other issues to worry about as well. Okay, so just leave it there, and just remember that internal variability of the MISOs may be limiting predictability of the seasonal monsoon rainfall.